Good afternoon to Cesaril and my friend. We will present our case study location. Before I start, I will introduce myself. My name is Fletcher Kela Leslie. Okay, for our introduction, we choose Jalan Wawasan and Jalan Setia for our intersection. We choose this intersection because it is the most used road in Muka City. Many vehicles pass this road and cause traffic congestion. This event usually happen on work hour and after work hour. This congestion problems because there is already stop sign built on the road, but the area lack of traffic light and one of the signage is broken down. Our objective is to study and improve the area, like repair broken signage, repaint the line on the road, and build an traffic light. Okay, this is our location for our case study. As you can see, this is the confliction at the road. They have three types of conflicts. Number one is through, right, and left. And amount of conflict at each road is 4 for each other. Okay, I think that's all from me. I will pass to my friend.
Traffic management involves controlling the flow of vehicles and pedestrians to ensure smooth and safe movement on roads, typically through the use of signal, sign, and other regulatory measures. Road damage characterized by bleeding refers to a situation where axis bitumen or asphalt create a glossy, sticky surface, and edge drop-off occurs when there's a sudden change in pavement height at the road edge. Both issues can cause safety risks and typically require corrective measures like resealing for bleeding and addressing the edge drop-off to ensure a smooth and even road surface. Preventive maintenance. This proactive approach involves regularly scheduled tasks and inspections to identify and address potential issues before they lead to equipment failures. It aims to sustain the reliability and longevity of equipment through timely upkeep. Next is corrective maintenance. When unexpected failures occur, corrective maintenance comes into play. It focuses on reactive repairs and troubleshooting to restore equipment to its operational state swiftly and efficiently, minimizing downtime. Next is predictive maintenance. Leveraging data analytics and monitoring tools. Predictive maintenance anticipated equipment failures by identifying patterns and trends. By analyzing the condition of assets in real time, organizations can optimize maintenance schedule and minimize disruptions.
Next is routine maintenance. This involves regular, planned activities to keep equipment in optimal working condition. Routine maintenance tasks include cleaning, lubrication, and minor adjustment, ensuring that system operate efficiently and adhere to prescribed standard. Then breakdown maintenance. In response to sudden equipment failure or breakdowns, this type of maintenance focus on immediate repairs. It is a reactive strategy aimed at quickly addressing issues to restore functionality and mitigate any adverse impact on operation. Next is condition-based maintenance. By continuously monitoring the actual condition of equipment through sensor and diagnostic, condition-based maintenance enable organization to make informed decisions about when maintenance is necessary. This approach minimizes unnecessary intervention and maximizes the lifespan of equipment. Next is emergency maintenance. Emergency maintenance, on the other hand, refers to unscheduled maintenance tasks that are immediate due to urgent and critical situation. While breakdown often lead to emergency maintenance can also be prompted by other unforeseen circumstances such as safety concern or environmental risk. Next is recommendation for bleeding. Bitumen or asphalt materials appear to bleed through the surface, requires a multifaceted approach encompassing both short-term remedies and long-term strategies. The following recommendations are tailored to mitigate the bleeding road problem effectively. The first recommendation is immediate surface treatment. Implement immediate surface treatment to alleviate the bleeding. This may include the application of anti-stripping agent or absorbent materials to absorb excess asphalt or bitumen on the road surface. Quick intervention can help minimize safety hazard and prevent further degradation. Second recommendation is in-depth pavement assessment. Conduct a comprehensive pavement assessment to identify the root cause of the bleeding. This should involve a thorough analysis of pavement structure, material use, and environmental factors influencing the pavement performance. Engaging civil engineers and pavement experts is crucial for a detailed evaluation. Third recommendation for bleeding is material testing and specification review. Re-evaluate the asphalt or bitumen material specifications to ensure they align with the local climate conditions. Conduct material testing to assess the compatibility of the asphalt mix with the environmental factor, including temperature variation and moisture level. Adjusting the mix design may be necessary to improve adhesion and stability.
For the recommendation in the edge drop-offs on road involves a combination of preventive measures, infrastructure improvement, and ongoing maintenance strategies. So the following recommendations aim to address edge drop-off problem effectively. So the first one is regular inspections and monitoring. To implement routine inspection of roads to identify and address edge drop-off issues promptly. Regular monitoring can help detect potential hazard early on to preventing safety risks for motorists. So the second one is maintenance of road shoulders. To ensure proper maintenance of road shoulders to prevent erosion and degradation. Regularly inspect and repair shoulders to avoid the formation of significant drop-offs, especially in areas prone to soil erosion. In the discussion, the civil engineering department students were given a new assessment which requires us to investigate an intersection. We were divided into groups of 4 members. Our group members was Muhammad Alif Kayum bin Abdurrahman, Sean Benzagi, anak River Nodon, which is me, Fletcher Kilah Leslie, and Afif Fahan bin Abdul Talib. The selected location of our intersection is at Mukah, Sarawak. The specific address is at Jalan Wawasan and Jalan Setia, Mukah, Sarawak. We have acknowledged that there are several road damages at the intersection. If no action is taken, the risk for accident to happen will get higher day by day. The intersection should and will come in for more attention, particularly where more effort can be devoted to the improvement of the intersection. One of flag of the intersection is the road damage. So, in conclusion, the case study of the intersection highlights the intricate dynamics and challenges associated with urban traffic management. The intersection, being a focal point of vehicular and pedestrian movement, requires a comprehensive approach to optimize efficiency, ensure safety, and minimize congestion. Several key observations and recommendations emerged from the analysis. During our case study at Jalan Wawasan and Jalan Setia Muka, there is a lot of gap improvement that government or JKR can do.